discuss analysis of variance, and we will use SigmaXL to perform that test. Now, what is analysis of variance? It is a hypothesis test that determines if there is a statistically significant difference between the means of 3 or more groups. You're likely familiar with the student's t-test, also called the 2t test, which is used to compare the means between two groups. ANOVA is used when you have 3 or more groups, right? So 3 or more groups, and these 3 groups or more groups, they are from a categorical variable. So what's the different time in shifts? Do average sales vary across different regions? Is the average procurement time for supplier 1, supplier 2, and supplier 3 different? When you have to answer questions like these, you would use ANOVA. Now, you would want to ask, what's the problem with students' 2T test? If it can be used to compare the means of 2 groups, why can we not use it for 3 groups or more groups, right? If we set up the test sequentially, here is how we would set it up. We would have 3 different hypotheses. First one would be that the mean of group 1 is equal to group 2, and the alternative that it's not. Then a mean of group 1 equal to group 3, and mean of group 2 equal to group 3, and their corresponding alternative hypothesis. However, as the number of groups would increase, the accuracy of the results would decrease. So for 5 groups, for example, at an alpha level of 0.05, you would have 0.95 raised to the power of 5. So the probability of the hypothesis being simultaneously correct would be 0.77. And if the number of groups increases to, say, 10, it would be even lower. This is what's called the expanding alpha problem or the alpha inflation problem. But thanks to the great British statistician Ronald Fisher, we have the ANOVA test, which avoids exactly this problem. Now, we call it ANOVA, and it compares means. So where is the variance in this? So what is mean? Mean is ultimately the average value of any continuous variable, meaning that anything that can be measured. So cycle time, handle time, processing time, weight, cost, revenue, these are all continuous variables. And despite its name, ANOVA compares means, not variances, and we'll shortly explore where the variance is involved. Now let us look at the null and alternative hypothesis for ANOVA. The null hypothesis is that all group means are equal. There's no difference between the groups, right? The alternative hypothesis is that at least one group mean is different from the others. Now let's use the example of a pizza chain restaurant that's trying to answer the question, 2 different generations, Gen Z, millennials, and boomers, spend money on orders differently, right? So in setting up ANOVA tests, the most commonly used terminology is factors and response variable. So in this case, we have only one factor and one response variable. The one factor is age group, within which there are 3 subgroups, Gen Zs, millennials, and boomers. And there is one response variable, which is the money spent in the restaurant or the order value. What happens when we do a 2-way ANOVA? Here, in addition to age group, we also have date type as a factor. So basically there are 2 factors here, age group and date type. So the response variable is still the same. It's the money spent per order, but now we are checking if there is a difference between, say, Gen Z spending money on weekday versus weekends, millennials spending money on weekdays versus weekend, and boomers spending money on weekday versus weekend, right? Another interesting question that a 2-way ANOVA can answer is there interaction? Is there an interaction effect or not? It's a very interesting concept, and we will discuss it in detail. at this point, what we can say is, what interaction means is, do boomers spend, for example, do boomers spend even more on weekends while Gen Z's trend stays flat? That would be an example of interaction effects. So two-way ANOVA has basically three hypotheses. The first two are standard. They're what you would expect to find in a one-way ANOVA as well. That in our example, for example, that all age groups, the mean would be equal. That would be the null hypothesis. The other null hypothesis would be that the spending on weekdays, the average spending on weekdays would be equal to the average spending on weekends. And the third one would be about interaction, where the null hypothesis would be that there is no interaction in the factors, and the alternative hypothesis would be that the effect of one factor, say weekend versus weekday, would depend on the other factor. So as an example, if boomers spend more on weekends but Gen Zs don't, that's an interaction, right? Now, moving on, there is something called the F-statistic and the V in the ANOVA. So I mentioned that ANOVA is a test of means, but it involves comparing variation. So F-statistic, as we call it, is the ratio of the variance between groups and the variance within groups. Now, think of it like this. There are three groups here: Gen Zs, millennials, and boomers. There is within group variation. So in Gen Z, you have spending as low as 18.5 and as high as 22.3. So this represents variation within this group. And then we also have between group variation. So how far apart are the group averages from each other? Gen Z's average is about 20, millennials is about 23, and boomers is about 30. So that gap between the means, that's what's called the between group variation. An easier way to think of it, another way to think of it is intergroup versus intra-group variation. And the F statistic, named again after Ronald Fisher, what this statistic measures is it's a ratio. It measures the variance between groups and the variance within groups, and then it decides whether the difference is significant or not, right? Now, I want to discuss the F statistic and the corresponding p value. So if given that F, as we discussed, F statistic is a ratio. So if the difference between the group averages is truly large, it's truly significant, then between group variation will be large relative to the within group variation. What does that mean? So if you have between group variation, which is high, and within group variation, which is low, that's where you would typically, in this quadrant, you would expect to see a significant result, which means a large F statistic. Here as well, you could see a significant result where the between group variation is high and the within group variation is high. That's possible because we are talking about ratio, so it's the ratio that matter, not the absolute value. And similarly for p values, if the between group variation is high and the within group variation is low, you would get a significant result. That is a small p value. That is a p value that's less than 0.05, meaning that you would end up rejecting the null hypothesis. Now, having covered the basics, let's do a couple of actual ANOVA tests and discuss the results. So here in Excel, I have two tabs, one for one-way ANOVA and the other for two-way ANOVA. Let's do the one-way first. So I have data here, age group and order value, millennials, boomers, Gen Zs. I'll simply select the table. The easiest way to do that is to do Control-Shift-8, go to SigmaXL, statistical tools, and one-way ANOVA and means matrix. It already shows that it's able to recognize what we've highlighted. So it's selecting the data set already. We will keep use data labels checked and go to next. Right. Here it's saying we will use the unstacked column chart and we will use order value. I'm sorry, we will use stacked column chart. We will use order value under numeric, and group category will be age group. We'll click on options. We will have this checked, and we will also do the Tukey's test, right? Leave everything else checked as it. We would want to look at the residual plots. That's one of the assumptions for ANOVA test. Although ANOVA is pretty robust to some departures from normality, we'll also leave these two unchecked. When we click OK, SigmaXL will create a couple of tabs for us. So let's give it one moment to do that. And we have, as I mentioned, we have two tabs here. Let's start reviewing the first one. So we can see there are multiple values here. Let's discuss these two first, the F statistic and the p-value. Right now the F statistic is 477.53. Looks like a huge number. And we have an F distribution table here. Let's compare it with the distribution table here first. So here we have 2 degrees of one column and one row to look at. So basically 2 sections where we need to look at. We will look at DF denominator and DF numerator. So the DF numerator would be K minus 1, so that would be 3 minus 1. So 3 were the number of categories, Gen Zs, millennials, and boomers. So 3 minus 1, 2. And for DF2, it would be, the denominator would be N minus K. So that's 90. There were a total of 90 data points. Minus K, which is 3, so 87 rows. Now, if I scroll down here, you'll see that 87 is not listed. But what we have is 60 and 120. So 60 statistic is about 5.79, 120 is 5.54. So we can assume that 87 would lie somewhere between these two values. But we also know that our own value that SigmaXL calculated was 477.53, which is a lot higher than these two calculated values. If assuming our values, our value lies somewhere in between, right? So and our calculated value is much higher, which means we can reject the null hypothesis. This is also confirmed by the p-value. The p-value is 0. It's less than 0.05, which is our alpha level. So we reject the null hypothesis here. So what's the takeaway at this point in time? The takeaway is that the group means are not equal. The spending by the 3 groups is not equal. Gen Zs, millennials, and boomers, they don't spend the same amount of money in the pizza restaurant, right? Now let's also view the Tukey probabilities. This was something that we had checked in the dialog box, and let's review each cell and do that pairwise comparison, right? So boomers versus Gen Z is 0.0. Millennials, boomers versus millennials is 0.0. And Gen Z's versus millennials is also 0.0. Everything else is blank because it's just a mirror cell. Now, ANOVA results had told us that there is a difference somewhere. What Tukey probabilities tell us exactly where, and in this case, all three age groups spend significantly differently from each other, right? And before we do the two-way ANOVA, let's view one of the assumptions for ANOVA's validity. Here are the residuals, right? If we look at this residual plot here, it's roughly bell-shaped. It's not as nice of a bell shape as we would like it to be, but it's roughly bell-shaped. This is also confirmed by the normality assumption here, right? So all in all, the test results are pretty robust. We can be quite confident in these p-values, in the p-value and in the F-statistic. What's the overall takeaway for the business? The overall takeaway is that the three age groups, boomers, Gen Zs, and millennials, they spend significantly differently. If you want, as the restaurant, if the restaurant wants to boost its revenue, it should focus marketing on boomers or find ways to upsell to younger customers. So that's our one-way ANOVA. Now we also have a two-way ANOVA, right? Let's look at the data for two-way ANOVA. So we have, in addition to age group, this time around we also have the day type, weekday versus weekend. And just to quickly recall, to remind you of what two-way ANOVA does, it basically has three separate tests. So the first test is that all the age groups means are equal. The second is that the weekdays versus weekend, there's no difference. That's the null hypothesis. And the third one is that there is no interaction, right? So let's go ahead and do Control-Shift-8. Again, select the whole data range. Go to Statistical Tools, and this time around, we select two-way ANOVA, right? Same as last time, SigmaXL is able to highlight our selection, and we will keep this checked. Use data labels because there are data labels on top. When we click next, we have numeric data variable, which will be the order value. Group category factor. The first one would be age group. The next one would be date type. As always, we want the residual plots. I don't think anything else is needed. The confidence level standard is 95%. Once we click OK again, SigmaXL should generate a couple of tabs for us, and we'll give it one moment to do that. Okay, looks like, yeah, our results are ready. So we can start with the interpretation. Now, these are the three things, these are the three hypothesis tests and the results for us to view. The first two, age group and day type, both have p-values of 0, meaning that they are less than 0.05. Both of them are significant. So for the age group, we can conclude that the age group spend significantly differently. For the day type as well, we can conclude that weekend spending is higher compared to weekday. But for interaction, we have a value of 0.15, which means that it is more than 0.05, which means, in other words, it's not significant. What does this mean? This means that the weekend boost is similar across all generations. Now, this will become clearer in just a moment when we start reviewing the interaction plots. Now, let's look at the interaction plots, right? Especially the the last one here, which is a combination of all of these. There are 4 interaction plots. There are 4 graphs here and 2 interaction plots. This interaction plot is the one that we are most interested in, because these lines here are roughly parallel, and parallel lines signify no interaction. So we already know from our p-value that our interaction test is not significant, but we also can confirm that using this interaction plot. These lines are roughly parallel. So what's happening here is Boomer's data has been plotted for weekday and weekend. Gen Z's data has been plotted for weekday and weekend, and Millennials data has been plotted for weekday and weekend. And we see that they are roughly parallel, right? And that signifies no interaction. But why? That's because parallel lines mean that the slope is same across all groups, meaning that every age group spending increases roughly by the same amount on weekends. So on weekday they have a certain level of spending. On weekend all of them have a jump in their spending, so a $4 to $5 boost across all groups. If there was interaction, then these lines would have had a different slope. Maybe they would have even intersected, right? So let's quickly also, now that we've covered the p-values and the interaction plots, let's look at the residuals as well. Here again, we have roughly a bell-shaped curve. It's better than the one, the first one for one-way ANOVA. But I should mention that ANOVA is pretty robust to small deviations from normality. So this is a pretty acceptable results, and we can be very confident in our p-values and in the test outcomes. All said and done, on the basis of these two ANOVA tests, what can we say? What's the takeaway for the business? That's what this exercise is all about, right? So the takeaway is that both age group and day type matter for spending. Everyone spends more on weekends, but since there is no interaction as per this interaction plot and this p-value, any weekend promotion would lift all age group spending equally. The restaurant does not need separate strategies for each age group on weekends. And that brings us to the end of this session. Hope you found this video useful. Thank you for watching.